So in this case, you have y equals 3x plus b. But the question is, well, how do we get b, right? Remember, let me scroll up a bit. Either these points both have to be on the line, so they have to be solutions to that equation. In other words, when x is 2, y has to be 2. And when x is 4, y has to be 8. Okay, so let's take x and y to be 2. And that's what I did here. Doing so, we get 2 is 3 times 2 plus b. So 2 is equal to 6 plus b. And again, we want to figure out what b is, right? We want to solve for b. So what do? Subtract. Subtract 6 from both sides. Okay? We get negative 4 equals b. So b is negative 4, and this is the line. That's what we get there. Let me get rid of this. Good. All right. So now let's look at the third one. This one's a little bit easier because one of the points is the origin. So the slope's actually pretty easy, right? Here we have negative 4, right? So again, we want to get the slope. So change in y, negative 4 minus 0, right? Wait, you know what? I don't know if you can see that here. Negative 4 minus 0. But again, you divide by the corresponding change in x. Negative 1 minus 0. That's what we also do. So what we end up with is negative 4 minus 0 over negative 1 minus 0. And we get 4 as our slope, right? Because we have negative 4 over negative 1. But that's the same thing here. You know what? Let me write that. 4 over negative 1. That's equal to 4. So same thing. I mean, what I had was right. I just added that extra step so people understand. All right. So that's what we have. That's what we have here. And again, let's get an equation of that. Right? Normally, if I ask you to do this on a test, quiz, or whatever, you don't have to give me all these equations for the line. You just have to give me one. I just like to put all the possibilities. But for instance, if you use the first point, once you get the slope 4, using the first point in point slope form, you have y minus negative 4, right? That's the y coordinate, equals 4, the slope, times x minus negative 1. And so from here, we're going to get y plus 4 is equal to 4 times x plus 1. That's what we get. Okay, good. Now, that's if you use the first point. I probably would have used the origin. That's a lot easier, right? Mostly because you would have y minus 0 would be 4 times x minus 0. And hopefully it's easy to see. That's just y equals 4 times x. This is also the slope-intercept form. Right? If you went to y equals 4x plus b, just by comparing, you'd be able to see that b has to be 0. I mean, not to mention, since the origin is on the line, the y-intercept and the x-intercept are both equal to 0. All right. Are there any questions on this? Okay. All right, so the next one, we want to find the equation of a circle whose center is 2, 3, and the radius is 5. Okay, well, if you remember, I was going to write in my Microsoft whiteboard, but, well, that's all right. If you remember, for the general form of the equation of a circle, It's always x minus h squared plus y minus k squared, right? Again, hk is the center of the circle, and that's equal to r squared. R, right, is the radius. You know what? Let me see if I can type it. So always going to look like this: x minus h squared plus y minus k squared. That's equal to r squared. This is a circle whose center is hk and radius r. So r is a positive number. But now, since the center is going to be 2, 3, right? Essentially here, your h is going to be 2 and your k is going to be 3. Because again, the center is 2, 3. So we take h to be 2, k to be 3, and r, of course, is 5, so we just plug it in. And this is what we get down here. This is what we get down here. Okay, that's good. Now, how would we know if the point 1, 2 is on the circle? Well, if it's on the circle, it has to be a solution to this equation. It has to be a solution to this equation, right? To be on the graph, right? The graph of an equation, right? It's all solution. It's the plot of all the solutions, all the ordered pairs that are solutions, I should say. So if 1, 2 to be on the circle, it has to be a solution of the equation. Now, does that happen? Well, let's see. Scroll down a bit. If you plug in x for 1, y for 2, right? We plug it in here, as you can see. On the left here, you get -1 squared plus -1 squared. On the right, though, you're not going to get 25. So this is not true. So this is not a solution of the equation. It's not on the circle. Okay. Any questions on that? Didn't get this far in the other class, but Microsoft Whiteboard is not cooperating, so let's keep going. I don't know if it's the app or the internet connection. Well, whatever. Here's another question. Let's find an equation of a circle whose center is the point 2, 4. And let's say it passes through 1, 1. So 2, 4 is the center of the circle, okay? 1, 1 is on the circle. Well, remember, the distance between the center of the circle and any point on the circle is the radius. I mean, I wrote it here, but I'll say it again as well. The distance between the center of the circle and any point on the circle has to be the radius. And for the equation of a circle, we need the center and we need the radius. We need the center and the radius. So let's get the radius, right? So what do? We have to get the distance between the center and the point 1, 1. Okay, but we just use our distance formula. So we plug it in, right? We have the square root of 2 minus 1 squared, right? This is the distance between 2, 4 and 1, 1, right? Change in x coordinates plus change in y coordinates squared. So we have the square root of 2 minus 1 squared plus 4 minus 1 squared. And then we take the square root of that, right? So this becomes 1 squared plus 3 squared, which is 1 plus 9. And we get the square root of 10. So the radius is the square root of 10. that means r squared is 10. So, no, that's fine. So the radius is 10. Let me write that out. Add it in for everyone. So the radius is the square root of 10. R squared then is 10. And that's how we get our equation of the circle here. That's what we get. All right. Are there any questions on that? All right, let's keep going then. So now we have this equation, 10x minus 3y equals 15. We're going to find the x and the y-intercept of this equation, right? It's really just like what I did in the lecture slides. Namely, for the x-intercept, we set y to be 0, and we solve for x. Okay, so we set x equal to 0. Excuse me, y equal to 0, and we solve for x. So we get 10 times x equals 15, right? So 10x equals 15, right? Because when you set y to be 0, the 3y part is gone. So you divide by 10, because we want to get x, and we get x is 15 over 10, which is 3 over 2, which is, of course, 1.5. Now that's the x-intercept. For the y-intercept, it's the same idea, except you basically switch the roles of the variables. Namely, for the y-intercept, you let x be 0. Now when x is 0, right, you're going to have 10 times 0 minus 3 times y equals 15. And that boils down to just minus 3y equals 15, right? So we have this equation to solve, but this one's actually not that bad. You basically just divide by -3, right? Because you want to get y, and you get -5. Okay, did I? Oh, there's the graph. Good. So we have our 2 points, right? Oh, here it is. 15 over 10 is 3 over 2, which is 1.5. And since we had y equal to 0, we get this point. That's for the x-intercept. For the one we just did, we set x to be 0 and y is -5. And below is the graph. This, again, I sketched in. Let me zoom out a bit. I sketched in Desmos, but this is what the graph would look like. All right. And the one below at number 5 is actually almost identical. All right. You know what? We have like few. Okay, we're out of time, actually.